A musical instrument is made using long tube with mouthpiece at one end. The other end is open and flare. As shown, as musician maintain stationism with a note at the mouthpiece and antinote at the other end. The lowest frequency K. So this long tube is work as open tube stationary wave, where the fundamental wavelength rate here is a quarter. So this is note and it's connected to antinote. Yeah, it's connected to antinote here to create antinote, to create the one wavelength. This is antinote. It's a quarter wavelength. Yeah, it works. It works as open tube. Yeah, open tube stationary wave, where the fundamental wavelength rate of the open tube is half wavelength. So the series of frequency in open tube is begin with 1 frequency, 3 frequency, and 5 frequency. Yes, so we see the list of this one F3 F5 frequency that fits to the answer. So this is the first frequency is 92, and how this is 276. Yeah, and 5 frequency, it means 5 times 92, it's equals to um 460. So the answer that fit to this result is C. The diagram show the shape at one instant in time of breadstick. Okay, which I think it's question of progressive wave. Yeah, progressive wave, which in unit 7. Yeah, so we can skip it. 18. Vibrating turning fork is held above glass cylinder filled to the top with water. The water level steadily lower. A loud sound is first heard when the life is 83.5 above the bench. The next loud sound, okay. A loud sound is first heard when the water level is 83. So this is the first loud sound. This is the first fundamental frequency, and it creates quarter wavelength when the water is at this point before it's decreasing, right? Okay, so this is now, and this is antinote. The next load zone is heard when the water level is here. Okay, so the water level decrease into 71, and then we can listen the next loud sound, and it create another stationary wave, another loop. So we just connect it. This is a note. This is note. So we're just connecting the line of the wave here to note, from note to note. Okay, so we have quarter plus half wavelength, and then we have 3/4 wavelength. On this length, okay, I mean, this level like 3.5 to 70.1 is 8 half wavelength. So half wavelength is equal to the 83.5 minus 2.1. And the half wavelength is equals to so the wavelength here is equals to 1 centimeter or equals to 1.328 meter. So what is the frequency of turning fork? The general speed equation V equals to lambda times F, where lambda is 1.328 times oh, frequency 340. So the frequency is 340 equals 1.328. It's equals to 256 hertz. The answer is B. A loudspeaker is set up at the open end. At the open end of closed tube containing powder, when the loudspeaker produces sound of frequency 1200 Hz, stationary wave. Okay, the speed of sound is 336. What is the value of distance x? So distance x is equal to, this is node, yeah. It's informed here that the powder gathers at the node. So this is node, and then we draw the line wave here, the wave line. So we have 1.5 wavelength or 3/2 wavelength. Okay. So we must calculate. We must calculate. We must calculate the wavelength here. So V equals to lambda times F. Lambda is equals to V per frequency, where V is 336 per 1200. It's equals to 0.28 meter. Yeah, so 3/2 times 0.28, it's equal to 0.42 meter, or it's equals to 42 centimeter. So the answer is B. Next, a long glass tube is almost completely immersed in a large tank of water. A louder sound is first heard when the height of the end of the tube above the water is 18.8. So first one is 18.8, and the next sound is heard when second height is rising at 56.4. Okay. We know that from the first height to this height is spread by half wave length. Yeah. Every each low each louder sound is at half wavelength to the stationary wave pattern. So the frequency, and then okay, we calculate the half of wavelength. Half of wavelength equals to 56.4 minus 18.8. It's equals to, then the wavelength it's equals 5.2 centimeter. Okay, the frequency is V per lambda. V is 330 per lambda is 0.752. Yeah, it's equals to 438, or we round up into 440 hertz. So the answer is B. Next, a pipe has length of 2 meter. Okay. Okay, what is the wavelength of the sun? First, we calculate how many wavelength create here. So this is NT naught, not, not, NT naught. 1, 1 half, 1 plus 3 per 4 wavelength. And it's equals to 7 per 4 wavelength. It con yeah, it happen in 2 meter, and then wavelength equals to 4 times 2 divided by 7. 1.1 meter. The answer is B. A guitar string vibrates to create a sound. The speed, okay. Okay. Yeah, yeah. Which graph show the variation of frequency of with the wavelength? Okay. First, we have to know that frequency to the wavelength, the relation is inversely proportional. So the diagram is curve decrease hyperbolic. Yeah, it's curve parabolic. So A and B are wrong answers. So look at the CD. What's different between CD is we have to focus on the speed. On the speed is 40. The speed wave, the speed, the speed of wave. The higher speed, v and speed and wavelength are proportion. So the higher speed, the longer, the higher speed is the longer wavelength. Yeah, so we can take this. We see from the first point, this is the same frequency in string and air, but what makes different are the air. The air here happened in this lambda, and the string here happen in this lambda. So you know, the more go right, the more go right, the more the wavelength go right, this is the longer wavelength. Yeah, the more coordinates x axis, uh it's more, yeah, it's getting more longer. eh, Yeah, so the string must be above the air. Yeah, because the wavelength is longer here. To the right, more longer wavelength. Okay, so the answer is C.